kind of straightforward here with our data and take a peek at some breakdowns of what things are, what the pieces are, what the names of some things are. So a histogram is going to use bars. Now, here's the thing. We're going to be dealing with bars, pie graphs, dot plots, scatter plots, all those different things, so we can kind of see what the good and bad of each of them are. So today we're using bars to show the distribution of our data. We're going to take a lot of data. I mean, not as much as like hundreds of bits, but again, tens, into the teens with numbers. And then into ranges that we call bins. Sort of like if you're doing, my son does things with Legos. He likes to take them, we get the different bowls and things out, we're getting the colors spread out, so I can find my colors and things a little more easily. That's kind of what we're going to be doing here, except we're putting numbers into certain ranges so we can tell our data story a little bit better. So this first one that we've got here that's labeled talks a little bit about some test grades in class if you wanted to make this look a little neater with things. Along our x-axis, or along the bottom, we got the ranges of grades. Typically, our bars are going to touch, okay? We get a title, how many people are in each group, things like that. But what I want you to notice is that not necessarily every group along the bottom here is the same amount. What I mean is 90 to 100, okay? That's like the A range, that 10% range. And our B range, and our C, and our D, 10 numbers, 10 numbers, 10 numbers, each in between. But that first one, 60, that's a really large group. We're glad it's a small group. But it wouldn't make a lot of sense for a teacher to have 0 to 10, 10 to 19, 20 to 29, for all those things. In that group, it's just the students that didn't pass. And then my couple of you that came in, if you missed it, we've got new packets in the back, so make sure that you've got those. Otherwise, you're going to look and go, where's Bertie coming up with this stuff? So what we're going to want to see from this is a few things. So let's see here. How many students took the test? So let's see. Each of our bars represent... Ooh. How many students got 60 to 69?
3, 2.
Ooh, the argument's in. Is it 2 or 3?
3.
3. Okay, because we're in between here, in between 2 and 4. So occasionally, we may get a number that doesn't necessarily go straight to one of our bars, and that's okay. So here, we're just going to add up 2, 5, 11, 18. 18 students, looks like a plan to me. We can get straight data out of things. How many students scored 0 to 59? Okay, especially if we put a number in there, that's pretty straightforward to see. But then at times, we're going to have to be a little more cautious. Now this is kind of funny. You can tell this is not, here at Harlem. How many students passed? They put 70 plus. Dang, I'm like, dang. So, okay. Yep, nice. So we just kind of ignore the other ones here and add up the ones to the left. 13, perfect. Ooh. What percentage of students, this is going to be interesting, scored 80 or higher? Now, how would I go about doing that? Let's do this in pieces. All right, first part. How many students scored 80 or higher? 7. How many total do we have in the class again? 18. So if I'm trying to find the percentage that scored 80 or higher, so here's my 80 plus group. Here's my total number of students in the class. So 7 divided by 18 gets me this decimally thing. We're going to go to the nearest whole here. But it's not going to be, so if I just divided and went to the nearest whole, we'll say 0.39, something like that. But I don't want to put 0.39 because that's not my percentage. Yeah, it'd just be 39%. Because whatever that decimal is, if I want to turn it into a percentage, I would just multiply it by 100. Now again, if you'd have put 38.8 or 38.9, that's fine, okay? Again, the idea there is that we're getting it from that decimal into a percent. So we have some other applications that we can do. Oh, students recorded the amount of minutes they spent on homework last night. I'd thought about doing a survey of that in here, to do that in here, but I'm like, I could get frightened. I could get frightened by that. So it'd be like, some of you would be a lot, some would be like 0, 0, 0, and then I'd be like, oh no. Well, we still got one here. So here's what we got to figure out first if we're going to make a histogram. Like, how big are our ranges going to be? So let's check this a bit. There's our smallest number. There's our biggest number. So we're rolling between 0 and 60 here in total. I mean, I don't want to have too many bars, but I don't want to have too few. So any ideas on like how many we should make each bar worth? Okay. So if we went in tens, let's see. So we'd be looking at 0 to 9 because we'd want 10 in the tens group. So let's see what this would look like if we tried this. I'm always a fan when I'm going to make any chart or graph of kind of jotting down my data before I start, because then if it looks like it's not going to work, I could always change it. Let's do this. Play this game. So if I went this route, here's what I mean by check my data. I'm curious on how many are in each part, because I want this to look accurate to somebody who's coming to look at it. So let's see here, 0 to 9, I think that's the only one. So we got one of those. 10 to 19, so we got 1, 2, 3, 4 of those. 20 to 29, we got 1, 2, 3. 30 to 39, 1, 2, 2 of those. 40 to 49, we got 2 of those. No 50s, okay. And one that's 60 or more. So again, I can make this look any way I want to. This seems pretty well spread out. So let's roll with this. But then I'm going to show you a way, if I wanted to make it look really bad for students, I could make this chart look awful. We don't want to do that, but just saying. So I notice my smallest group is going to be 0, and my largest group is going to be 4. So I really don't need my quantity side, my number of students side here, to be any more than my biggest number. That's why I like to do this in advance. And whenever we're doing this, we've got to make sure we're labeling stuff. So we're like, okay, we've got the amount of minutes. That's what we're going to roll with down here. Even if you just wrote minutes would be fine. How might I want to label, though, my vertical axis with my 0 to 4 here? What's that represent? Yeah. We could do that as well. And so as I get ready to make the histogram, I want to make sure that when I'm labeling accurately like I did here. So I'm going to write kind of small here. So like for 0 to 9, I had 1. So I'm going to get my first bar in here. I got colors to play with, but well, actually, let's use the same color. So 10 to 19, I got 4s. But I do want things to look a little different. So we can use designs, you could shade in, you could not shade in, and kind of do that. But again, with histograms, we typically are going to have them just touching to make a nice smooth line. Because if we get into a little more data like we do later, we start seeing which side they kind of lean to. Let's see, we haven't done squiggles yet. And I got to learn how to draw smaller. Or just make these a little less wide might have helped me here. Now, when we get to 50 to 59, even though it's 0, we need to have a space there for it. So people know that we didn't just forget it. Oh, we'll extend this a little bit. And we can see how this goes. Now, as I was saying at the start, this is just to kind of show you something real quick. To make data say what you want it to. So if I'm a teacher and I'm trying to make it look like my students never do homework, like ever. So I'd sit there maybe with the same plan and I'd be like, all right, so here's my students. So how could I make this look where students, I'm like, they don't do anything at all. So let's do, same exact data, but I decided I'm just going to make 2 bar set. Look at all these students that just do like 0 to, now, I don't mention the 59 part, but you don't know that 0 to 59. Do 14 of them do no homework and one does 59 minutes? We don't know. That's too big of a range and makes it look like everybody's getting clumped together. That's why we always want to try as best we can to spread it out so we can see really accurately how the data really is falling. So just something to keep in mind, because you'll probably at some point here have one of these to do on your own. So one other thing we can do with the bar graphs or the histograms, we can interpret information. We can get other information from them. We can even calculate things and make assumptions at some point. Bit of a scientist mode here. So when we're grabbing all of this stuff, okay, again, bar graphs, histograms, we're basically here, kind of mentioning again, repeating back through, we're using solid bars. Like tomorrow we're going to be talking about pie graphs, another option that we have here. When we're doing these, okay, most of the time, not every time though, most of the time the bars that we deal with can be horizontal or they can be vertical. They can be up and down, they can be side to side. Sometimes that can affect how we look at it, depending on what we want people to think about the information that we have. But no matter which direction they're going, up, down, left, right, the longer the bar, the greater the value, because there's more of a quantity there, like there were with the students that we just got done doing. And then if we want to know all of the data, you know, in this case, how many dogs were there, how many students were there, things like that, the sum, or adding up all the bars, would give us that data. So sometimes we may have to do a little bit of digging to actually see what something means in the big picture. So here, Gigi's seeing how many different types of dogs that she breeds, how many of each type to kind of, I don't know, maybe she makes decisions on supplies or something like that. So we need to get a total number here to be able to do math with this. So we're going to take each of our bars. Now, sometimes this is going to get interesting. I look at the dachshund here. How many dachshunds does that look like? Yeah, I think I'd go with that.
There are big little lines in the.
Oh yeah, they just didn't come through real well, did they? You're right. I can see those now that you mentioned it. So okay, that's helpful. That's very helpful. So here are Maltese 10, 11, 12. It's like my eyes were just opened by you saying that. 1, 2, 3, so 8 pugs. Schnauzer, that at least went to a whole number here. Oh, and I hear the calculators going already, so we're getting, some of you are going to tell me how many dogs there are total before I'm even there.
80.
80. I knew it. So we got 80 total. Oh my gosh, I hope it's not all at once. I can't imagine. That would be heaven for my wife who loves dogs, and for me I'd be like, oh dear gracious, what the heck is going on? All right. What percent, of the dogs are poodles? Okay. 2 ways you can tackle this. You can either make a proportion out of this and say, hey, there's 20 poodles. There's 80 total dogs. Proportion-wise, if I didn't want to deal with the decimal stuff, I could do this. And whenever we have a proportion, we're just going to cross multiply. If we got to here, 2,000 divided by 80 would be 25%. Well, I don't have to move any decimals with this. But you also could do what we did on the first page, which is just do 20 divided by 80, which is 0.25, and either in your head move the decimal point or just move it 2 places to the right. So it's kind of your call on that. They both get me to the right place, just depends on which one makes more sense. So percentages, that's always an option for us. Pugs. Here, this time I'll do it that other way so we can kind of see here. If you like the proportion, keep doing the proportion. But I can do the decimal and then just multiply by 100, and that will also tell me the percentage. So bar graphs have more use than just, point at it, there's 20 poodles or something. We can do more things. Ooh, ratios. Okay. What is the ratio of pugs and Yorkies? All right, pugs and Yorkies to Malteses. Now, when we're doing the ratios is just a fancy word for fraction. We still want to simplify this as much as we can. So we want to see if 1612 gets to be less. So math enter would be a wonderful thing here. So for every 4 pugs and Yorkies, 3 Malteses are being groomed. So just a quick reminder here that math enter can help us out when we're doing anything with fractions if we want them a little bit less. Ooh. What breed of dog? Okay, we're not going to be told. Is 15% of the total dogs being groomed? You're like, okay, so what do we got here? Well, first thing, 15% is 15 out of 100. And we know, okay, this is the percent out of the total. Well, we know how many total dogs there are. We know there's 80. We want to know which one of them represents 15%. So again, I'll show you two ways you can do this. I still think this is probably going to be the easiest. So if we divide both sides by 100, we need to find the dog of which 12 were groomed, which would be the Maltese dogs. Okay, so anytime we're asking for what percentage, percentages can always be something over 100. Now let me grab a different color here. I will show you one other way you could do that. You could just do 15% as a decimal, and I know there's 80 dogs, and I can get the 12 that way too. So again, it depends on what makes sense to you. Percentage as a fraction, percentage as a decimal. You're doing the same thing mathematically, just have more options to do it. And so down on the bottom, just a couple quick last ones here. Mark the following statements as true or false. The ratio of pugs to Malteses is 2 to 3. And let's see here. Pugs to Maltese. This is just like a fraction. Okay, this is like 8 divided by 12. The colon is just a different way of writing a ratio. We don't like decimals. Math, enter. 2/3 would be 2 to 3. So that would be true because when we simplified it, we got it back. The Dachshunds, Pugs, and Yorkies are equally represented in the total number of dogs. Now let's see here. Dachshund is 7. Pug is 8. Yorkie is 8. Yeah, no. Equally represented? I don't think so. You better go find another Dachshund. Otherwise, that's not true. Schnauzers represent 5/16. Oh my, of the dogs being groomed. Okay, let's see. Schnauzers out of the total. I don't know. No decimals. Math, enter. 5/16. So lots of things can be taken from bar graphs besides just, here's a straight number for me to be kind of fed with that. So, a little bit of practice to play, a little bit of practice. So, as you finish up taking a peek at that, over into the practice packet. I'm just looking at things here. Let's say, for now, I'm just looking here for a second to see. Ooh. Okay, let's start here. Today we're going to start with page 1 because I just noticed there's one question that I had on here that we haven't gotten to yet. So when you get to number 5 here, go past that one unless you know how to play with that yet. To estimate the average or the mean age of the people surveyed, we're going to have to do a little bit of addition and dividing, but that's not something I want to play with today. It's coming. That's going to be part of what this cycle is, but I just didn't realize that question was on there right away. So we'll skip number 5, but the rest of them we should be able to get some percentages and some things down with that.